Welcome to the very first video on aptitude test, and we are talking about sequence and series. This kinds of knowledge is very important in various competitive examinations, so let's jump into it. And today we are talking about sequence and series, and I will give you some general ideas on what they are. So let's get started. There are many types of series or progressions, but we will talk about arithmetic progression and geometric progression in this video. These two are, let's say, the most used series in various examinations. So let's talk about arithmetic progression. In arithmetic progression, there you will be given a sequence of numbers. You will be presented with many numbers and you will have to find a pattern among those numbers. The difference of second term and the first term is what we call as a common difference in arithmetic progression, and by adding that number to the very first number of the series we get the second number, and so on. So if you are having some confusion about it, let's see. In our first example, see the sequence is 1 2 3 4 5 6 and so on. So I think it's really easy to notice that the second number in this series is obtained by adding 1 to the first term of the series. So what we have here is 2. We get this 2 by adding 1, and this 3 we get by adding 1 to the second term. The fourth term we get the third term by adding 1, and so on. So the difference between these two numbers, either 2 or 1 or 3 or 2 or 4 or 3 or 5 or 4, it doesn't really matter. The difference of any two consecutive numbers in a series is called common difference, and the next number in the series is obtained by adding that number to the series. Let's go for a second example. In second example, the series starts at 3. So to get the second number, if you see the difference, there's a difference of 2. So the second number 5 was generated by adding 2 to the very first term. So if you look at the third term, the 7 was obtained by adding 2. On the second term, 9, we got this 9 by adding 2 to 7, and 9 plus 2 is 11, 11 plus 2 is 13. So the next number is 13 plus 2, that is 15. So this is the way this series has progressed. Let's go to third example. In third example, the first number is 5. This is also called first term. The first term of the series is 5. The second term is 10. Third term is 15. So if you look at the difference, we can see that 10 minus 5 is 5, and 15 minus 10 is also 5. Similarly, 20 minus 15 is 5. So we can say that the common difference in this sequence is 5. So 5 plus 5 10, 10 plus 5 15, 15 plus 5 20, 20 plus 5 25, 25 plus 5 30, 30 plus 5 is 35, and then 40, and then 45, and then so on. So this series progress in this way. Now let's go to fourth example. In fourth example, our very first term is 70. You can see that the second number was obtained by subtracting 5 to first number. So the common difference here is minus 5. The common difference won't always be positive, it can also very well be negative, so you have to keep that in mind. So 70 minus 5 is 65, 5 minus 5 is 60, minus 5 is 55, 55 minus 5 is 50. So that's the way this series has progressed. So I hope you have some basic understanding of AP now. So let's move on to GP. In GP, two numbers increases or decreases very rapidly. In this case, let's say you have 1, the second term is 3, and 9, and then 27. So you can see that these numbers are increasing very rapidly. So in GP, the next number is obtained either by multiplying or by dividing the number. So we multiply or divide. So if you look at this series, you can see that the second number is obtained by multiplying 3 to first term. So 3 into 1, 3. This 9 was obtained by multiplying 3 to the second term. 3 into 3, 9. 3 into 9, 27, and the next number will be 27 into 3. Let's go to second example. In second example, you can see that it starts with 1, and then it's 2, 4, 8, 16, 32. You can see that these numbers are increasing very rapidly. See, if the same sequence here, if you compare with the AP in this one, you can see that the increase is very gradual here, but here the increase is quite fast. So it can be GP. So if you are not sure if something is AP or GP, you can have some idea just by looking at this sequence of numbers. Rapidly increasing or decreasing might indicate some GP. So in this one, we obtain this second number by multiplying 2. So the common ratio is second term divided by first term. This is called common difference, and R is called common ratio. This is obtained by dividing second term by first term. So what we have here is that the common ratio here is 2 by 1, 2 divided by 1, so that's 2. So this number is obtained by multiplying 2 to this one. 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16, 16 into 2 is 32. I hope that was clear. Let's go to third example. In third example, we have 27, 9, 3 and 1. You can also notice here that these numbers are decreasing very fast. So here the common ratio is 9 by 27 means 1 by 3. 7 by 3 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. And the next number will be 1 by 3, and then 1 by 9, and then 1 by 27, and then so on. Let's go to fourth example. In fourth example, you can see that the first term is 1, then 5, 25, 1, 25. So I hope you have already got the answer on this one. The common ratio we are looking here is 5. 1 into 5 is 5, 5 into 5 is 25, 25 into 5 is 125, and next number is 125 into 5. So this is the basic example of APs and GPs. Now it's time to learn some formulas regarding APs and GPs. These formulas will help you in obtaining answer very rapidly. So let's jump into formula number 1. The nth term of AP. So the nth term means any term in AP. See, this is an AP. This is one kind of AP. The nth term may be this is first term, this is second term, this is third, this is fourth, and the another one is fifth term. By looking at this, you are sure that this number is 5, but you can calculate that number by using a formula, and that formula is this one, where A is the very first term. In this case it's 1, and n is the number you are trying to obtain. If you want to find another number after 4, the n is 5 because it's the fourth term. 1 first term, second term, third term, fourth term, and the last is its fifth term. If you want to find what is on the 10th position, the n will be 10. So it is n minus 1, and D is common difference. Common difference, as we have discussed earlier, is 2 minus 1, or 3 minus 2, or 4 minus 3. Essentially they will come out the same. So to find n term, the formula is A, which is first term, plus n minus 1 D. The second term in our formula is sum of AP. So if you want to find sum of AP, how much is 1 plus 2 plus 3 plus 4? If you want to find the sum of numbers which are in arithmetic progression, you use this formula. And let's discuss the term here. The n, as in the first one, is number of terms. How many terms do you want to calculate that sum up to? So let's take this example again. If you want to calculate sum of first 4 terms, then n is 4. Okay, so n by 2, it is 4 by 2. And a always signifies the first term. Okay, a signifies first term, which is 1. And in our case, if we have last term, this one is L. Okay, this one is L. L is the last term. If you want to find sum of 1 plus 2 plus 3 plus 4, L is last term. So using this formula we get n, which is 4 in this case, the number of term 4, and a, this is 1, and L, which is again 4. Please don't get confused with the last term and the last number. Okay, the last term in our example is 4, and the last number happens to be 4. It can be anything else, but it happens to be 4 in this example, so don't get confused about this. So the sum will be a, this is 1, L is 4, 4 plus 1 is 5 into 4 by 2. Okay, 4 by 2 is 2, 5 into 2 10. So let's see if that is right. 4, 5, 6, 7, 8, 9 plus 1 is 10. So this is the first sum of numbers in AP. If you know what the last term is, okay, if you know what the last term is, but if you don't know what the last term is, then there is another formula for that, and this is the formula you are looking for. The formula is n by 2, 2a. N is the number of term you want to find sum up to. Let's take the same series and you want to find the sum up to 10. So you want to find the sum of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. If you want to find sum of that, then the n is 10. Okay, so 2 into a, which is first term, is 1, plus n is 10, because we want to find sum of the 10th term, sum up to 10th term. So this is 10 minus 1, and d is common difference, that is 2 minus 1 or 3 minus 2 or 4 minus 3, they are the same. So the formula is this one. Okay, now we can use this formula to find the sum of the series. Now let's go to another formula. The another formula is sum of natural numbers, that is 1 plus 2 plus 3 plus 4. Again, this formula is obtained from the formula we already have for sums in AP. We just substituted 1 for a, and d is also 1, so this formula will reduce to this one. So the main point I am trying to make is that in competitive examination you have very limited time, and processing this one might take you longer. So if you can add another equation to your memory, it's better that you know the formula is n by 2 n plus 1 for sum of natural numbers. That way you will have a better chance of saving some time, because this calculation will take a bit longer than this one if you know the direct formula. Now let's go to another formula. Another is sum of odd numbers. The sum of odd numbers is n square. Okay, it's very straightforward formula. What the sum of odd numbers means, it's 1, 3, 5, 7 and 9. Okay, 11. Since it's n square, it's fairly straightforward. N is the number of terms you want the sum to. If you want sum of these two, then n is 2. So 2 square is 2, 3 plus 2 square is 4, and 3 plus 1 is 4. If you want sum of these 3 terms, then n is 3. 3 square is 9. So if you sum up these 3, 5 plus 3 plus 1, it's 9. If you add sum of first 4 terms, it's 4 square, it's 16. So if you sum this up, it will come out to be 16. 7 plus 5 is 12. 12 plus 3 is 15. 15 plus 1 is 16. Okay, now let's go to another formula. Sum of even numbers. The sum of even numbers formula is n plus 1. Okay, this formula is used to calculate sum of first n even natural numbers. So the first n is even natural numbers starts from 2, it's 4, it's 6, it's 8 and 10, and then 12 and 14, and then 16. Even numbers are those numbers which are divisible by 2, and odds are numbers which are not divisible by 2. Sum of even numbers is n plus 1. Again, n is number of terms. If you want sum of these two, then n is 2. If you want sum of these three numbers, n is 3. If you want to sum of these terms, then it's 4. I hope you are getting my point. Now another formula is sum of first n cubes. So if you want sum of 1 cube plus 2 cube plus 3 cube plus 4 cube, then this is the formula, n plus 1 by 2, and you square that whole thing. So essentially you get the sum of this one. Again, n is the number of terms. If you want sum of these two, then n is 2. If you want sum of these three, n is 3, and so on. The last formula in my list is sum of square of first n natural numbers. So natural numbers starts from 1, it's 1, 2, 3, 4, 5, 6, 7, 8. These are called natural numbers, and their square is 1 square, 2 square, 3 square. And if you want sum of these things, so sum of square of first n natural number is this one, n plus 1 to n plus 1 by 6. The formula we have studied here is somewhat related to arithmetic progression, because this formula can be obtained by simplifying this one, and this formula is also obtained by simplifying this formula. Okay, and this formula was also obtained by using this formula. In GP, the nth term, any term in GP is given by ARn minus 1. So let's take an example here. Let's say we have GP of 3, 9 and then 27. So the A here is 3, the R is 9 divided by 3, which is 3, and n is, if you are taking first term, this is n is 1 in this case. If there are two terms, n is 2, and if question asks you to find the fourth term, then n is 4. So this equation essentially becomes 3 into 3 to the power n, which is 4 minus 1. I hope you are getting my point here. To find sum of GP, we have two formulas here. The first one is ARn minus 1 divided by r minus 1. A 1 minus r to the power n by 1 minus r. But if you look at these two formulas carefully, they are nothing but they are the same, with some modifications to accommodate for r. If r is greater than 1, in this case it is, we use this formula to find the sum. If you want to find sum of 3 plus 9, you use this formula. But if I reverse this sequence, if the sequence was reversed, then the r here would have been 1 divided by 3, and as you can guess, it is less than 1, so we use this formula. Okay, so these two formulas are just to make your calculation a bit easier. You essentially don't have to remember these two formulas and do your calculation as it is, but your calculation will be easier